Hey everybody, in this video we're going to talk about inverse functions. So let's start with the definition. So if f of x is a function, then the inverse of f of x is its inverse function. Alright, so it's going to be the inverse function. Now something to keep in mind with this -1, this is not an exponent. Okay, so this is just a notation that shows that we're talking about the inverse function. So don't think about that as a negative exponent, okay? Two very different things. So if we have the inverse of f of x, what that does is it reverses the actions of f of x. So whatever happens with f of x, the inverse should reverse that action, whatever is happening there. So let's look at a specific example. So let's say we've got f of x equaling 3x minus 4. Now if you recall, this f of x, this is the same thing as saying y. So we have actually the equation or the function y equals 3x minus 4. So how do we find that inverse function? Well, we're going to reverse our x and our y variables. And then we're going to, so we got x equals 3y minus 4, and now we're going to solve for y. We're basically going to get y back by itself. So we'll add 4 to both sides and divide everything by 3, and we get our inverse function to be x plus 4 over 3. Alright? So if this thing reverses the actions of f of x, what happens if we plug a value in here? Well, let's take f of 1. So this is going into the original equation. What happens if we put 1 into f of x? Well, we've got 3 times 1 minus 4, and that gives us a value of -1. So when x is 1, f of x is -1. What happens if we put -1 into the inverse? Well, if it reverses, something should happen here. So we're going to have -1 plus 4 over 3, and as you do your computations there, that's going to give us 1. So it kind of took us back to the original, the beginning. So that's kind of what we mean by it reverses the actions of f of x. So is there a way that we could write this in a general notation? Well, let's take a look at this specific example to see how this would work, to see how this might undo. So we're going to use our specific example of 3x minus 4 to write up our general formula. So we got f, the composite of the inverse of f of x with f of x. Okay? So f of the inverse of f of x. So what that means is the inverse is going to go inside the original function. So we're going to have 3 times x plus 4 over 3 minus 4. So if you notice the inverse function, x plus 4 over 3, went into the x function, the x placement in the original function. Alright, so now as we start simplifying, we can see that these 3's are going to cancel out. We've got x plus 4 minus 4, and those 4's are going to cancel out, and we're left with just x. So the composite with the inverse function going inside the original function gives us just a value of x. What happens if we flip these two things around? What if we have the inverse of f of x with the function f of x inside that? So the composite of f of x and the inverse of f of x. What's going to happen there? Well, again, let's plug this in. So that means the original function, 3x minus 4, is going to go into our inverse, which is x plus 4 over 3. So this thing has to go in the numerator, plus 4 over 3. Alright, so let's start simplifying. Here we can drop the parentheses and basically think of these 4's canceling each other out. And we're left with 3x over 3, and those cancel out, so we're left with just x. So even when we're not using numbers, we can see that these two functions cancel each other out, and we're left with just the original thing that we started with, x. Alright, so this is kind of like a good key idea to remember, that these two things both equal each other and they both equal x. So let's look at an example with this. So we've got f of x equaling x squared. Now if you remember, if we graph this, we're going to get this nice kind of parabola going through the origin here. And if we want to find the inverse of this, we have to reverse the variables So we're going to have y equals x squared, swap those out, so x equals y squared. Solve for y, so that means we have to take the square root of both sides, and we're going to have plus or minus square root of x. We have to include that plus or minus because we don't know if x is positive or negative. So we've got y equals plus or minus square root of x. So now, what happens if we substitute these two things into each other? So will we get x? So the inverse, the plus or minus square root of x, is going to go into our original function. So we're going to have that squared. So we have to look at it in two pieces. We've got to look at the positive piece and the negative piece. So let's look at the positive piece. If we have a positive square root of x squared, then that's going to equal x, right? Because the positive is like a positive 1. 1 squared is 1. Square root of x squared. The square root and the square cancel out, you're left with x. What about the negative? Well, that also is going to equal x, right? Even though we've got a negative out front, if we take negative 1 times negative 1, if we square that negative 1, we get a positive 1. And same, if we square a square root of x, then we have x. So this meets the rules for a function, right? No, it's actually not a function. And you're probably thinking, well, wait a minute, you just told me that if these two things work, if they both come out and cancel out to x, then we've got an inverse function. But the inverse of f of x is the inverse function, right? So this of f of x. And that's the key thing. It's the function of f of x. So what is the main idea of a function? Well, let's look at it with a graph. So if we graph this, and we have the first part is going to be kind of this top curve, the part of the parabola turned on its side, and that's the positive square root of x. And the negative square root of x is going to be down here on the bottom side. So we kind of have the parabola turned on its side. So the definition of a function says that no one x can have two different y values. So here we've got a place where one x equals two different y values. So this inverse f of x is not an inverse function. It's not a function. It's not passing that basic rule of a function. But what it is it is a relation. So it's an inverse relationship to the original function. Okay, so this is probably seeming a little confusing to you. So let's try and summarize it. So the main thing that I want to get across is that some, and again, let me say some functions may not have inverse functions. All right? So they may not actually have an inverse function, but they will have an inverse relationship or inverse relation, depending on how you want to say it. Okay? So that doesn't mean that all functions are not going to have their inverses or that all functions will. You just have to be careful and not make these broad sweeping generalizations. You kind of have to look at each individual function to see if the inverse is a function or not. And what's one way that you can do that? Well, just like we did here with the inverse function, we checked using the vertical line test. Now you could go through and you can solve the inverse, find the inverse function. You can graph that and then do the vertical line test. Or you could use a horizontal line test. A horizontal line test on the original function. So if we do the horizontal, that's going to use the same idea of doing a vertical with the tilted or the translated, rotated function, inverse relation. So you have to make sure that we're keeping these things straight. So by doing the horizontal line test, you're getting the same results as doing the vertical line test of the inverse. All right, so it's just kind of a quick way to do it, to do a check there. So hopefully from this you're able to get the definition of what an inverse function is, the difference between an inverse function and an inverse relationship. But really the main idea is that you're going to have to look at each individual situation. But you should now at least have the skills to find that inverse and then just make sure that you are determining whether it's a function or a relation. That's it for this one, and we'll talk to you in the next video.